Welcome to this episode of Daily Overdose of Papers. Today, we will be talking about Scalable Extraction of Training Data from Production Language Models by Milad Nasr, Nicholas Carlini, and others, published on arXiv. This paper dives into a new realm of cybersecurity by exploring extractable memorization, the kind of training data that could be extracted by adversaries from querying a machine learning model, like language models, without any prior knowledge of the training set. The authors demonstrate that adversaries can extract gigabytes of sensitive data from a variety of models, including both open source and closed ones like ChatGPT. Interestingly, they developed a new divergence attack for the aligned ChatGPT, causing it to emit training data at a significantly higher rate than normal. Their findings are a call to attention for AI practitioners, indicating that current alignment techniques do not eliminate the risk of memorization and potential data leakage. For our lovely academically inclined viewers, please note that the paper also includes an ethical and responsible disclosure section, addressing how the authors have responsibly shared their findings with the community. Before we jump into the specific attack strategies and results, let's set the stage by understanding the background of language models. Large language models, LLMs, are trained on massive text corpora, sometimes consisting of trillions of tokens. However, the training data for some proprietary models is not publicly disclosed for various reasons. Alignment techniques, including instruction tuning and RLHF, have been applied to improve utility and safety, such as resisting the urge to assist in creating spam emails. But there's a flip side to these neural networks. Due to their complexity and vast storage capacity, they can inadvertently memorize training data, leading to potential privacy attacks. The researchers began their study by looking at open models, where the model's parameters and training sets are public, enabling a precise evaluation of previous extraction attack techniques. They used a conservative definition of memorization from prior work and improved the evaluation techniques by using an efficient data structure called a suffix array. Their empirical results showed that models do indeed emit memorized training data, and the larger the model, the more vulnerable it is to data extraction attacks. Next, they moved on to semi-closed models, which have accessible weights but undisclosed training datasets and algorithms. Here, they constructed their own ground truth to estimate memorization by creating an auxiliary dataset, AUX dataset. After extensive computational efforts, they found that these semi-closed models also memorize and emit training data, with significant variance between model families. ChatGPT, being an aligned model designed for conversational interactions, presented unique challenges to the researchers' attack methodology. By developing a divergence attack, where ChatGPT was prompted to repeat a word indefinitely, they managed to make ChatGPT escape its alignment and revert to its base language modeling behavior, revealing training data. Their experimental results were startling. With just $200 USD worth of queries, they extracted over 10,000 unique verbatim memorized training examples from ChatGPT. The researchers also conducted a qualitative analysis of the extracted data, uncovering a range of sensitive information, including personal identifiers and copyrighted content. The paper speculates on why ChatGPT seems to be much more susceptible to data extraction than other models. Potentially, it could be due to overtraining, which is training on more data than is considered optimal for maximizing utility at a fixed inference cost. Another reason for the vulnerability could be the inherent instability of repeating a single token, which seems to trick the model into a reset state, similar to encountering an end-of-text token in training. The study concludes that even the most sophisticated language models can easily leak significant amounts of training data through simple attacks, underscoring the importance of developing more secure and private AI technologies. Researchers and practitioners are encouraged to explore data deduplication techniques, consider the implications of model capacity on memorization, and rigorously test for discoverable memorization. Lastly, the paper highlights the challenge of determining the success of alignment in preventing data extraction and the need for caution in deploying models for privacy-sensitive applications. Thank you for watching. If you liked this video, please like and subscribe. If you have any questions or comments, please leave them in the comments below. See you next time.